had vanished into the darkness. The conversation might have ended there, filed away as an interesting anomaly, a puzzle for future astronomers to revisit. But in the months that followed, something else began to happen. People started noticing things. The first reports came from amateur astronomers, hobbyists who spent their nights scanning the sky with backyard telescopes. They posted on forums and message boards, describing brief flashes of light that appeared and disappeared in seconds. The flashes didn't match known satellites or meteors. They seemed to occur in random patches of sky, far from the ecliptic plane where most solar system objects traveled. When other observers tried to verify the sightings, they found nothing. The sky remained dark and still. By the summer of 2018, the reports had multiplied. A man in Oregon recorded a video showing 3 points of light moving in formation across the night sky before winking out simultaneously. A woman in Chile photographed what appeared to be a faint streak that didn't match any known satellite trajectory. A group of students in Japan set up an automated camera system and captured dozens of unexplained flashes over the course of a month. The incidents were scattered, inconsistent. No two reports described exactly the same phenomenon. Some observers saw brief glints of reflected light. Others reported objects that seemed to change direction mid-flight. A few claimed to have seen larger structures, dark shapes that blocked out stars as they moved. The details varied so widely that many dismissed the accounts as misidentifications, equipment malfunctions, or simple hoaxes. But the volume of reports kept growing. In online communities dedicated to astronomy and unexplained phenomena, people began to call the sightings by a new name. They referred to them as ATLAS events, a reference that seemed to emerge spontaneously from multiple sources at once. Some said the name came from an early forum post that described the objects as being everywhere, all at once, like the Titan from mythology who held up the sky. Others claimed it was an acronym, though no one could agree on what the letters stood for. The name spread quickly, becoming shorthand for something that remained frustratingly difficult to define. By 2019, the ATLAS phenomenon had attracted the attention of researchers outside the amateur community. A team at a university in Australia began compiling reports, trying to find patterns in the chaos of sightings. They built a database, cross-referencing locations, times, and descriptions. What they found was unsettling. The events seemed to cluster around certain dates. There would be weeks of silence, then suddenly dozens of reports would arrive from around the world within a 48-hour window. The clusters didn't correspond to meteor showers or other known astronomical events. They appeared to occur randomly, without warning. More troubling was the geographic distribution. Many of the sightings occurred over remote areas, far from cities and major population centers. Deserts, oceans, mountain ranges, places where few people would be looking up at the sky. The researchers realized that for every reported event, there might be dozens or hundreds that went unobserved. Everything went silent for a moment. Then, in March of 2020, during the early days of the global pandemic, something changed. A research station in Antarctica detected a signal. The station operated an array of radio telescopes designed to study cosmic radiation and map distant galaxies. On the night of March 14th, the instruments picked up a narrow-band transmission that lasted for 17 seconds before cutting off abruptly. The signal didn't match any known source. It wasn't coming from a satellite or ground station. The frequency was unusual. Most significantly, when the researchers analyzed the signal's origin point, they found it was coming from a location high above the planet, somewhere in the space between Earth and the Moon. The team tried to verify the detection, pointing their instruments back toward the source coordinates. They found nothing. The signal did not repeat. After 3 weeks of continuous monitoring, they published a brief technical paper describing the event as an anomaly of unknown origin. The paper was quietly shared among certain research communities. Most readers treated it as an interesting curiosity, a strange blip in the data that would likely never be explained. But a few people made a connection. The date of the signal, March 14th, fell precisely within one of the ATLAS event clusters that the Australian team had identified. By late 2020, the conversation had evolved. What began as scattered observations from amateur astronomers had become something more structured, more deliberate. Private researchers and independent analysts began treating ATLAS as a genuine phenomenon worthy of serious investigation. They built networks, shared data, developed protocols for verifying sightings. The reports continued to arrive. A pilot flying over the Pacific reported seeing lights beneath the ocean surface, moving at impossible speeds before vanishing. A satellite operator noticed temporary disruptions in GPS signals that coincided with reported ATLAS events. A meteorologist documented unexplained radar returns that appeared and disappeared without leaving any physical trace. None of the evidence was conclusive. Each incident, taken individually, could be explained away as equipment error, natural phenomena, or human misperception. But the pattern was becoming harder to ignore. Something was happening, something that didn't fit into existing categories. He paused. In 2021, an astronomer in Spain made an unusual discovery while reviewing old telescope data. She had been conducting a routine search for near-Earth asteroids, examining images captured over the previous 5 years. While comparing photographs of the same patch of sky taken months apart, she noticed something odd. In several images, there appeared to be objects that hadn't been there before, small dark points that blocked out background stars. The objects were tiny, barely visible even in enhanced images. They didn't appear in consecutive photographs, suggesting they were transient, present for only brief periods before moving on or disappearing entirely. Most astronomers would have dismissed them as image artifacts or distant satellites caught at unfortunate angles. But the Spanish researcher noticed something else. The positions of these objects, when plotted on a map of the solar system, formed a rough arc. The arc began near the trajectory that One Eye had followed when it passed through the inner solar system back in 2017. It extended outward, following a path that suggested the objects had entered from the same direction as the original interstellar visitor. The astronomer published her findings in a preprint server, presenting the data without offering firm conclusions. The response was mixed. Some colleagues praised her careful analysis. Others suggested she was seeing patterns in noise, connecting dots that had no real relationship. The debate remained technical, confined to academic circles. But outside those circles, the discovery resonated with people who had been following the ATLAS phenomenon. To them, the arc of objects represented something significant. Perhaps One Eye had not been alone. Perhaps it had been the first of many visitors. Or perhaps it had marked a path that others would follow. The speculation grew more elaborate. Online forums filled with theories about the nature of the objects, their purpose, their origin. Some suggested they were probes, sent by distant civilizations to explore other star systems. Others proposed they were natural phenomena, fragments of matter ejected from dying stars or colliding planets, drifting through the galaxy for eons before chance brought them near Earth. A few voices suggested something stranger, that the objects were not separate entities at all, but parts of a larger system, a network that extended far beyond human comprehension. The astronomical community largely avoided these discussions. The data remained ambiguous, and without concrete evidence, most professionals were reluctant to speculate publicly. But privately, in conversations over coffee or late-night emails between colleagues, some admitted they were troubled by what they were seeing. By 2022, the ATLAS phenomenon had taken on a life of its own. It existed in a strange space between scientific inquiry and cultural narrative, too documented to dismiss entirely, but too elusive to study systematically. Reports continued to arrive from around the world, each one adding another thread to an increasingly tangled tapestry. In June of that year, a deep space tracking station in California detected something unexpected. The station monitored satellites and debris in high orbits, maintaining awareness of objects that posed potential collision risks. During a routine scan, operators identified an unknown object at an altitude of approximately 35,000 kilometers, moving in a highly elliptical orbit that took it from near Earth out to the edge of the magnetosphere and back again. The object was small, perhaps the size of a car. It wasn't transmitting any signals and didn't match the profile of any known satellite. When the operators tried to obtain more information, consulting databases of registered spacecraft and debris, they found no records. The object appeared to be untracked, unregistered, and of unknown origin. For 3 days, the station monitored the object as it completed its unusual orbit. Then, on the 4th day, it was gone. The tracking system showed no sign of decay. The incident was reported to space agencies, but generated little official response. Unknown objects appeared in tracking systems occasionally, often turning out to be misidentified debris or errors in the detection algorithms. Without more information, there was little that could be done. But word of the detection spread through informal channels. Amateur researchers compared the object's orbital parameters with other ATLAS reports and found correlations that seemed too consistent to be coincidental. The altitude matched other suspected sightings. The timing fell within one of the identified event clusters. The sudden disappearance was consistent with the transient nature that characterized the phenomenon. A quiet moment passed. As 2023 arrived, something shifted in the way people talked about ATLAS. The initial excitement and speculation began to give way to something else, a kind of ambient unease that was harder to name. The phenomenon hadn't escalated or become more dramatic. If anything, the reports had become more routine, almost predictable in their unpredictability. But that constancy itself felt unsettling. There was a growing sense that whatever ATLAS represented, it wasn't going away. It had become part of the background, a persistent mystery that existed at the edges of perception. People who followed the reports found themselves looking up at the night sky more often, wondering what might be passing overhead unseen. Even those who remained skeptical couldn't entirely shake the feeling that something had changed. In August of 2023, a research paper was published in a minor scientific journal. The paper presented a statistical analysis of all confirmed ATLAS events over the previous 5 years. The authors had developed a model to account for observer bias, equipment limitations, and reporting inconsistencies. After filtering the data, they concluded that the probability of all events being explained by known phenomena was vanishingly small. The paper stopped short of offering explanations. It simply stated that something anomalous appeared to be occurring with statistical significance. The authors called for more systematic observation and data collection. They suggested that the scientific community had a responsibility to investigate the phenomenon more rigorously. The paper received little attention in mainstream scientific circles, but it represented a turning point of sorts, a formal acknowledgement that ATLAS was more than folklore or internet speculation. By the end of 2023, the phenomenon had settled into an uneasy equilibrium. Reports continued to arrive at a steady pace. Researchers maintained their databases and refined their models. Online communities discussed each new sighting, searching for meaning in the accumulating data. But no breakthrough came. No clear answers emerged. The visitor from beyond, that first object detected in 2017, remained the only confirmed interstellar object humanity had observed. Whether it had been singular or the first of many remained unknown. The ATLAS events continued, scattered across time and space like stars in an unfamiliar constellation, their pattern just beyond reach. He paused. People went about their lives. The world turned. But sometimes, on clear nights, when the sky stretched dark and vast overhead, individuals would stand outside and look up. They would think about the objects moving through the silence above, the things that passed unseen between the stars and the earth. They would wonder what else might be out there, drifting through the cosmic ocean, following trajectories that began in places unimaginably far away. The phenomenon had no resolution. It had no ending. It simply continued, night after night, a persistent mystery woven into the fabric of the sky. And perhaps that was the most unsettling aspect of all. Not that something strange was happening, but that it was happening quietly, continuously, without fanfare or explanation. The universe had always been vast and full of wonders. ATLAS was a reminder that some of those wonders remained beyond human understanding, moving through the darkness just out of sight, following purposes that might never be known. The reports kept coming. The databases grew. The sky remained full of secrets. And somewhere in the space between stars, in the cold and silent void where light took years to travel from one point to another, objects continued their ancient journeys, passing through the small corner of space that humanity called home, leaving only questions in their wake. Let your breathing slow now, just a little. There's nowhere you need to be but here, in this moment, as the day releases its hold on you. The world outside continues, but you are settling inward, into stillness, into the quiet space where thoughts can unfold without urgency. Tonight, we're going to think about something distant, something that passed through our solar system not so long ago, moving in silence, carrying no message we could hear. But first, let the tension leave your shoulders. On the 18th of October, 2017, a telescope in Hawaii noticed something unusual. The Pan-STARRS telescope, designed to watch for asteroids that might someday concern Earth, caught a glimpse of an object moving faster than it should. Not dramatically faster, not impossibly faster, just enough to be strange, enough to make astronomers pause and look again. They named it Oumuamua. In Hawaiian, it means scout or messenger, or the first to reach out, a name that carries both poetry and caution, as if we weren't sure yet what we were seeing. At first, they thought it might be a comet. Comets visit us regularly, after all, trailing their frozen breath across the darkness. But Oumuamua showed no tail, no glowing halo of dust and ice. It was something else. It was the first interstellar object ever confirmed to pass through our solar system, the first visitor from beyond. Imagine that for a moment, without alarm, without drama. For billions of years, our sun and its family of planets have traveled together through the galaxy. A small, self-contained neighborhood drifting through an ocean of space. We've watched our own rocks and ice balls circle the sun in their predictable paths. We've grown used to the furniture of our cosmic home, and then something arrived that didn't belong to us. Something that came from somewhere else entirely. The scientists worked quickly, because Oumuamua was already leaving. It had swung past the sun, caught in its gravity just long enough to curve around, and was now accelerating back out into the dark. They had only a few weeks to observe it before it would fade beyond the reach of even our most powerful instruments. What they learned was strange. The object was shaped unlike anything we'd seen before. Long and narrow, tumbling end over end as it traveled. Some calculations suggested it might be 10 times longer than it was wide. A cosmic cigar, one scientist said, though later observations suggested it might be more like a disc or a pancake. spinning as it flew. We still don't know its exact shape. We saw it only as a point of light, too far away for detail, too fast for a closer look. And then there was the acceleration. As Oumuamua moved away from the sun, it sped up. Not much, not the violent thrust of a rocket, but enough to be measured, enough to be real. Comets do this too, pushed by gas jets as their ice sublimates in the sun's heat. But Oumuamua, remember, showed no tail, no visible outgassing. So, what was pushing it? This is where the human mind begins its work. This is where we start telling ourselves stories. Because stories are how we make sense of the unknown. They're how we've always made sense of it. Before we had telescopes, we looked at lights in the sky and saw hunters, bears, gods, and omens. We wove narratives across the darkness, because narrative is the tool we have. Oumuamua gave us very little information. A shape we couldn't quite determine, a slight acceleration we couldn't quite explain. And in that gap between observation and understanding, the stories rushed in. Some scientists proposed it might be a shard of solid hydrogen, frozen in the deep cold between stars. Others suggested it could be a dust bunny of sorts, so light and fluffy that even gentle sunlight could push it. There were papers about nitrogen ice, about fractal structures, about thermal radiation pressure, and then there was the other idea, the one that captured imaginations. Avi Loeb, a respected astrophysicist at Harvard, suggested that Oumuamua might be artificial, not a natural object, but something made. Perhaps a light sail, a thin sheet of material designed to be pushed by starlight, sent by some distant civilization on a journey across the galaxy. Not an alien spacecraft exactly, not a flying saucer from a science fiction film, but perhaps a piece of technology, ancient and derelict, tumbling through space long after its makers had forgotten it or vanished entirely. The idea wasn't absurd. Scientists take strange hypotheses seriously when they're proposed carefully, with evidence and reasoning. Loeb's suggestion was based on the object's unusual acceleration and its possible shape. If it were thin and flat, sunlight alone might push it along, but most of his colleagues weren't convinced. The natural explanations, however unusual, seemed more likely than invoking alien engineers. Extraordinary claims require extraordinary evidence, as the saying goes. And Oumuamua had left us with more questions than answers. Here's what matters though, as you lie here breathing slowly, letting your mind drift through these ideas. The disagreement wasn't about fear. It wasn't about warning, or threat, or invasion. It was about curiosity, about trying to understand something genuinely new with the limited information we had. Some people heard about the alien hypothesis and felt a thrill. Others felt skeptical. Some felt both at once. But the object itself, whether rock or ice or ancient machine, had already passed us by. It was leaving. It had no interest in Earth. If it had interest at all, we were never the destination. We just happened to be here as it passed through. Think about that scale for a moment. The galaxy is unimaginably vast. Hundreds of billions of stars, each with their own space, their own possible worlds. The distances between them measured not in miles, but in light years. In the time it takes for light itself to cross the emptiness. If Oumuamua came from another star system, it might have been traveling for millions of years before it reached us. Millions of years, drifting in the dark, tumbling through nothing, with no one watching, no one aware of its journey. And if it was artificial, if some civilization built it and sent it out, that civilization might be gone now, turned to dust long before their messenger reached our small corner of space. Or they might still be there, living their lives, as unaware of us as we were of them. until this strange coincidence of trajectory brought their ancient craft close enough for us to notice. We live in a universe where such things are possible, where objects can wander between the stars, where the remnants of distant makers or distant nature can arrive at our doorstep without announcement, without explanation. This isn't frightening. It's simply vast, and we are small within it, but not insignificant. Our smallness doesn't diminish us. If anything, it reminds us that we're part of something much larger than ourselves, part of a cosmos that continues to surprise us, to offer us mysteries we haven't solved yet, and may never solve completely. After Oumuamua, astronomers started looking more carefully. They wondered if other interstellar visitors had passed through before, unnoticed. They improved their detection systems. They waited. In 2019, another one arrived. This time, definitely a comet, with a proper tail and everything. They named it Borisov, after the amateur astronomer who first spotted it. It behaved exactly as a comet should, following the laws of physics, with no surprises, no acceleration anomalies. Borisov reassured many people. It showed that interstellar objects could be ordinary after all. Just chunks of ice and rock, born around distant stars, knocked loose by gravitational encounters, drifting through the galaxy until they happened to pass near us. Normal, explainable, part of the natural order of things. But Oumuamua remained different, remained unexplained, and perhaps that's all right. Not everything needs to be solved tonight. Not everything needs to be solved at all. Not immediately. Not with certainty. We can live with questions. We've always lived with questions. The universe has been asking us riddles since we first looked up at the night sky, and we've been doing our best to answer, knowing we'll never be done. Oumuamua taught us that our solar system isn't as isolated as we thought, that travelers from other star systems can pass through our space, that we're connected to the broader galaxy in ways we're only beginning to understand. Whether it was a rock, a comet fragment, a shard of exotic ice, or something stranger, it expanded what we know is possible, and it left without harming us, without threatening us, without even noticing us, most likely. It was simply passing through. There's comfort in that, if you look for it. The universe is full of things moving according to their own paths, their own momentum, their own ancient trajectories. We cross paths with some of them. We observe them briefly. We wonder about them, and then they're gone. And we continue on our own way. Nothing is required of us except curiosity, except the willingness to look, to question, to accept that we don't always get the answers we want. The scientists who studied Oumuamua didn't panic. They didn't call for alarm or defense. They wrote papers. They debated. They disagreed with each other respectfully. They acknowledged what they knew and what they didn't. They did what humans do best when we're at our best. They tried to understand. By now, Oumuamua is far beyond the reach of our telescopes. It's somewhere in the space between stars again, tumbling in silence, heading wherever gravity and momentum take it. In thousands of years, it might pass near another star system, another world. Perhaps someone there will notice it too, and wonder where it came from. They won't know about us, won't know that it passed through our neighborhood once, long ago, and left us puzzling over its nature. The galaxy is full of such passages, such brief encounters, objects and light and energy moving through the dark, occasionally intersecting, occasionally witnessed, but mostly just traveling their long, slow journeys unseen. We happened to see one, just one, and it changed something in us. Even if only slightly, it reminded us that we're not separate from the rest of the cosmos, that our solar system has visitors, that the universe is more connected, more active, more surprising than we sometimes remember. Let yourself feel that now, without needing to grasp it completely. The vastness, the mystery. The simple fact that something traveled across light years of emptiness and came close enough for us to see, however briefly. You don't need to understand everything. You don't need to solve it. You just need to know that it happened. That it's out there, still traveling, still tumbling through the dark. And you're here, breathing slowly, safe in this moment. Part of the same universe that contains such wonders. Your breath is steady now, slow and natural, like the motion of planets, like the drift of stars across the sky. There's no urgency here, no need to figure anything out. The questions can wait. The mysteries will still be there tomorrow, and the day after, patient and enduring. For now, let your mind settle like dust after a wind. Let the thoughts about distant travelers and unexplained accelerations fade into the background, still there if you want them, but no longer demanding your attention. The universe continues, Oumuamua continues, and you continue too, here in this quiet space, breathing in and breathing out, connected to everything and responsible for nothing right now except rest. The darkness isn't empty. It's full of travelers, full of stories we haven't heard yet, full of light that hasn't reached us yet, crossing the vast distances at its patient, steady pace. And somewhere out there, something else might be on its way. Another visitor, another mystery, another reminder that the cosmos is larger and stranger than we usually take time to consider. But tonight, that's someone else's concern. Tonight, the only thing required of you is this breath, and the next one, and the quiet, settling into sleep. Let the universe keep its secrets for now. Let Oumuamua continue its journey, and let yourself drift, gently, into whatever comes next. Rest. Welcome to Midnight Whisper. Tonight we move slowly. Sit with your breath. Let the friction of urgency ease away. In this space, we do not demand answers. We gather questions and hold them like seeds. We will follow a quiet visitor from the deep between stars. 3i Atlas. We will not chase hysteria or sensationalism. Instead, we will listen to facts, to small wonders, and to the quiet thoughts they awaken in the midnight mind. Before we continue, may I ask you something? Where are you listening from right now? A room, a road, a late night shift, or a place between destinations? This is a long journey we're about to take, and I'll need your focus, your presence, right here with us. Did you know, in the summer of 2024, on a night like any other, a telescope in South Africa turned its lens toward a familiar patch of sky? The survey had been running for years, watching, cataloging, noting the slow drift of asteroids and the predictable paths of comets that circle our sun. But on this night, something moved differently. The object was faint. Not unusual in itself. Space is full of faint things, dim wanderers too small or too distant to catch much light. But this one moved at an angle that didn't quite fit. Its motion seemed wrong, as if it were cutting across the expected traffic rather than following it. The astronomers made note of it. They watched it again the following night, and the night after that. This was not one of ours. The object was moving too quickly, and in the wrong direction, to be bound to the sun. It had come from somewhere else, from the space between stars, and it was passing through. They named it Comet Atlas. In the careful language of astronomical catalogues, it became C/2024 S1. But among those who study such things, it earned another designation, 3i Atlas, the third interstellar object ever confirmed. The first had been Oumuamua, that strange elongated visitor in 2017, tumbling through our system before anyone quite understood what it was. The second was Borisov, a comet that arrived in 2019, more familiar in shape, trailing a tail of gas and dust that marked it clearly as something we recognized, even if it came from foreign skies. And now Atlas, the third messenger from beyond. There is something quietly profound about this number. 3. After Oumuamua, we wondered if we had witnessed something rare, a once-in-a-lifetime visitor. After Borisov, we began to understand that the space between stars is not as empty as we once imagined. These travelers pass through more often than we knew. We simply hadn't been watching carefully enough. Atlas became proof of a pattern, not an anomaly, not a threat, simply part of the larger truth about our galaxy, that things move through it, on journeys far longer than human lifetimes, crossing distances we can barely name. The early observations were fragmentary, a point of light, a calculated trajectory, estimates of size that were more educated guesses than measurements. Perhaps a few kilometers across, they said. Perhaps less. It was difficult to know for certain when the object was still so far away, so dim, reflecting only the faintest trace of sunlight. But as autumn arrived in 2024, more telescopes turned toward it. Space telescopes, free from the blur of Earth's atmosphere, captured clearer images. Ground observatories tracked its path with increasing precision. The picture began to sharpen. Atlas was a comet in the truest sense. As it drew closer to the sun's warmth, it began to outgas, releasing frozen materials that had been locked inside since its formation in some distant stellar system we would never know. A faint coma developed around its nucleus, that soft cloud of vapor and dust that gives comets their ghostly appearance. Scientists studied its spectrum, the light it reflected, searching for clues about its composition. Water ice, they found, carbon compounds, the building blocks familiar to comets born in our own solar system. Whatever distant star had once warmed this wanderer, it had formed Atlas from materials not so different from those that made our own worlds. This was oddly comforting. The universe, for all its vastness, seems to follow certain patterns: hydrogen and helium, carbon and oxygen, ice and rock. The same elements, arranged and rearranged across light years of space. By late autumn, word of Atlas had spread beyond academic journals and observatory bulletins. Amateur astronomers began searching for it in their own telescopes, comparing notes, sharing images captured from backyard observatories and dark sky sites far from city lights. For a brief time, Atlas became something rare in our modern world. A shared point of wonder. Not sensationalized, not frightening, simply interesting. A visitor from impossibly far away, close enough to see. Some who viewed it felt a quiet thrill, knowing they were looking at something that had traveled through the dark between stars for perhaps millions of years, only to pass through our small corner of space during this particular moment. Others found it humbling, a reminder of scale, of how small our concerns are against the backdrop of such journeys. The media took notice, as they always do when space offers something visible, something people can point to. But the story was, by its nature, gentle. Atlas posed no danger. Its trajectory was well understood. It would not collide with Earth. It would not even come particularly close. The closest approach to our planet came in mid-January of 2025. At its nearest, Atlas passed more than 100 million miles from Earth. To put that in perspective, the Sun sits 93 million miles away from us. Atlas came no closer than the distance between Earth and the Sun, plus another 10 million miles for good measure. This is not close. Not by any human measure. Not by any measure that should inspire concern. If you could somehow stand on Atlas during its flyby, Earth would appear as little more than a bright point of light, a pale blue dot, as one astronomer once called our world when seen from far away. We would look small from there, almost insignificant, just as Atlas looked small from here. This is the nature of space. Things are farther apart than our minds naturally comprehend. The distances are protective. They are buffers of emptiness, vast beyond imagining, that keep the cosmos from being crowded or dangerous. ATLAS continued forward after its closest approach, unaffected by Earth's gravity, barely influenced even by the Sun. Its path was set long ago, by forces and events we can only guess at. Perhaps it was ejected from its birth system by the gravitational dance of planets. Perhaps it was nudged loose by a passing star. Perhaps it simply drifted over unimaginable time until it found itself here. As January gave way to February, ATLAS began to fade. Not because it was changing, but because it was leaving, moving away from the Sun, away from Earth, away from the inner solar system where light is plentiful and reflection is easy. Telescopes continued to track it, but it grew dimmer each night. The amateur astronomers who had sought it out found it harder to spot, even from dark skies. The scientific observations continued, but the public attention, as it always does, moved on to other things. This is not callousness. It is simply the nature of human attention. We are creatures of the present, bound to what is immediate and changing. A comet that moves slowly across the sky, fading by degrees, cannot hold our focus the way sudden events do. But ATLAS continues its journey, whether we watch or not. In the months ahead, as 2025 unfolds, ATLAS will travel outward, past the orbits of Mars and Earth, past the asteroid belt, into the realm of the gas giants. Sometime around December of this year, it will make its closest approach to Jupiter. This is not a collision, not an encounter in any dramatic sense, simply a passing. ATLAS will sweep past the giant planet at a distance of several million miles, close enough that Jupiter's immense gravity will tug slightly on the comet's trajectory, bending its path by a small degree. This is how motion works in space. Everything affects everything else, but only proportionally. Jupiter is massive, but ATLAS is small and fast. The giant planet will tweak the comet's course, shaving a little time off its exit, or adding a small change in angle, but nothing more. From our perspective on Earth, this will be a quiet event. Just two objects passing in the dark, following the mathematics of orbital mechanics as they have done for billions of years. After Jupiter, there is only the long exit. ATLAS will continue outward, past Saturn's orbit, past Uranus and Neptune, into the cold outer reaches, where the sun's light is barely brighter than other stars. This will take years, many years. By the time it crosses the orbit of Neptune, sometime in the late 2020s or early 2030s, ATLAS will be invisible to all but the most powerful telescopes. Too far, too dim, too cold to see, but it will still be there. Eventually, it will leave the solar system entirely, not in any single dramatic moment, but gradually, crossing the invisible boundary where the sun's influence fades to nothing and the interstellar medium begins. This might happen in the 2030s, perhaps the 2040s. The exact timing depends on definitions, on where you draw the line between here and there. But what is certain is this: ATLAS will not return. Its orbit is not elliptical, not bound to the sun. It is hyperbolic, open-ended, a curve that leads only outward. ATLAS arrived from interstellar space, and to interstellar space, it will return. In 1,000 years, it will be farther from our sun than any human artifact has ever traveled. In 10,000 years, it will be light years away, crossing the dark between stars once more, perhaps passing near other suns, other planetary systems, other worlds we will never know. It will carry with it no message from us, no plaque or recording. It is not a probe sent with intention. It is simply matter in motion, following the path that physics set for it long before humans existed to name it or wonder about it. There is something peaceful in this understanding. ATLAS is neither ours to keep nor ours to fear. It is a visitor, brief by cosmic standards, unremarkable in the grand scope of galactic motion. We happened to be here when it passed. We happened to be watching. We happened to notice. And now it is leaving. This is the story of ATLAS. Not a story of danger or drama, but of distance and time. A story of something passing through, as all things do, on journeys too long for us to fully comprehend. The scientists who discovered it will move on to other observations. The telescopes will turn to other targets. The data collected during ATLAS's passage will be analyzed and published, added to the slow accumulation of knowledge about interstellar objects, about comets, about the material that drifts between the stars. Perhaps, years from now, someone will look back at the images of ATLAS and remember the brief time it was visible from Earth. Perhaps they will feel again that quiet sense of wonder at something so far from home, passing so close to ours. Or perhaps not. Memory is selective, and human attention is finite. We forget most of what we see, most of what happens, most of what passes through our awareness. But the universe does not forget, because the universe does not remember. It simply continues. Motion and gravity, light and dark, objects moving through the vast distances, unwitnessed and unconcerned with being witnessed. ATLAS will continue its journey long after the last human who saw it has passed away, long after our civilization has transformed into something unrecognizable, or perhaps vanished entirely, long after Earth itself has aged and changed, its continents rearranged, its species evolved into new forms or extinct. The comet will still be traveling, still moving through the dark, still carrying with it the ice and rock that formed around another star in another time, for reasons no one will ever fully know. This is the scale we live within, not just the scale of space, but the scale of time. Events that seem significant to us, that capture our attention and spark our curiosity, are the briefest of moments against the backdrop of cosmic motion. ATLAS's passage through our solar system will last a few years from detection to final departure. Its entire journey through the galaxy may last millions or billions of years, a span of time impossible to internalize, impossible to truly feel. We caught it in the middle of that journey. We saw it for a moment. We measured and photographed and wondered, and now we let it go. There is no sadness in this, no loss. ATLAS was never ours to keep. It was simply here, briefly, like all things that pass through our lives. A friend visiting from far away, a bird landing in the yard before taking flight again, a season changing into the next. We watch these things with appreciation for the brief time they are present. And when they depart, we do not chase them. We do not mourn their leaving. We simply acknowledge the visit, remember what we learned, and turn our attention to what comes next. The sky is full of such travelers, most of them too faint to see without powerful instruments, most passing unnoticed, unobserved, unnamed. They move through our solar system regularly, these small wanderers from between the stars, following trajectories set by ancient encounters we will never reconstruct. ATLAS is special only because we saw it, because we happened to be watching at the right time, with the right tools, with enough understanding to recognize what we were seeing. But in another sense, ATLAS is not special at all. It is ordinary. It is proof that the extraordinary is actually common, that what seems rare is only rare to notice, not rare to exist. This realization can be comforting. The universe is not sparse and empty. It is full of matter in motion, full of objects on long journeys, full of processes and patterns that continue whether we observe them or not. We are part of that fullness. Earth is part of that motion. We too are traveling, orbiting our sun, which itself orbits the center of our galaxy, which itself moves through the larger cosmic web of galaxy clusters and superclusters. Everything is in motion. Everything is on a journey. ATLAS is simply doing what everything does, at a scale and speed and trajectory that happen to bring it close enough for us to see. Now it recedes. Now it fades. Now it returns to being just another point of light, and then no light at all, invisible in the darkness between stars. But it is still there, still moving, still on its journey, and we are still here, still watching, still wondering. This is enough. This has always been enough. The story of ATLAS is the story of attention and release, of noticing what passes by, and then letting it pass, of measuring what can be measured, understanding what can be understood, and accepting that most things are beyond our reach. The comet moves on. The cosmos continues. And we, here on our small world, can rest in the knowledge that we saw something rare and beautiful, something from impossibly far away, and that we understood it for what it was, not a threat, not an omen, but simply a traveler passing through. The night sky remains, the stars remain, the vast distances remain. And in those distances, countless other objects move, on countless other journeys, unseen and unnamed, carrying their own stories that no one will ever fully know. This is the universe we inhabit, large beyond comprehension, ancient beyond measure, indifferent to our fears and fascinations, yet endlessly worthy of our attention and wonder. ATLAS has given us a gift, a reminder of that scale, that motion, that larger context we sometimes forget in our daily lives. It has reminded us that we live within something vast and old, something that continues with or without us, something that operates on timescales that make human concerns seem fleeting. And there is peace in that reminder. There is comfort in understanding our place within such immensity. We are not the center. We are not the purpose. We are simply here, briefly, witnesses to motion we did not cause and cannot control. This is not diminishment. This is perspective. The journey of ATLAS continues. Our observation of it ends. The two things are not the same, and that difference matters. What we see is not all that exists. What we name is not all that matters. What captures our attention is not more real than what escapes it. ATLAS exists in its own right, following its own path, indifferent to being seen or forgotten. And we exist in our own right, following our own paths, able to notice or not notice, able to wonder or not wonder, able to rest in the knowledge that the cosmos is full of such journeys, and that we are lucky enough to witness even a few of them. Let your breathing slow. Let your thoughts settle. Let the story of ATLAS fade into the quiet background of your awareness, just as the comet itself fades into the darkness of space. It is still there, still moving, still on its ancient journey. And you are here, still breathing, still resting, still safe in this moment, in this place, connected to the same universe that holds ATLAS in its vast embrace. The distances are protective. The motion is predictable. The darkness is not empty, but full of travelers on journeys longer than time. And you can rest now, knowing this, knowing that the cosmos continues, knowing that ATLAS, wherever it is, whatever unknown reaches it, crosses, is simply doing what comets do, moving through the dark, moving through the vast, between, moving on. So, the object was first spotted on a Wednesday afternoon in August of 2017. A telescope in Hawaii had been scanning the sky as it did every clear night, cataloging asteroids and comets, logging their trajectories into vast databases that few people would ever read. The astronomer on duty that day noticed something unusual in the data stream. An object was moving through the inner solar system, but its path didn't match anything they had seen before. At first, no one was certain what they were looking at. The trajectory suggested the object had come from somewhere beyond the solar system, drifting through the darkness between stars for millions of years before passing near the sun. It was moving fast, far too fast to have originated from the distant belt of icy bodies that encircled the outer planets. The numbers were checked and rechecked. The conclusion remained the same. By September, observatories around the world had turned their instruments toward the sky, trying to capture more information before the object disappeared into the void. It was small, perhaps a few hundred meters long, tumbling end over end as it traveled. Its surface seemed to reflect sunlight in strange ways, brighter than expected for a typical asteroid. Some observations suggested it was elongated, cigar-shaped, unlike the rounded or irregular chunks of rock that usually wandered through space. The astronomers gave it a designation. They called it 1I/2017 U1. In conversation, they shortened this to 1I. The name was technical, unremarkable, but what it represented was not. 1I was an interstellar object, the first ever confirmed to pass through the solar system. News of the discovery spread through scientific communities and then into the wider world. Articles appeared in journals and magazines. Late-night programs discussed the visitor from beyond. Most of the coverage focused on the historic nature of the detection. The fact that humanity had finally witnessed something from another star system passing through its cosmic neighborhood. The tone was celebratory, curious. But there were anomalies in the data that didn't fit neatly into explanations. As 1I moved away from the sun, accelerating slightly as it climbed back out toward the edge of the solar system, something unexpected appeared in the calculations. The object was speeding up in a way that couldn't be explained by gravity alone. A quiet moment passed. Comets sometimes behaved this way. When they drew close to the sun, their icy surfaces would heat and release jets of gas, giving them a small push. But 1I showed no signs of such activity. No tail, no cloud of dust or vapor. Its surface remained inert, reflective, silent. Yet the acceleration was there in the numbers, consistent across multiple observations. Theories began to emerge. Perhaps the object was made of frozen hydrogen, a substance so rare and volatile that it wouldn't leave visible traces as it vaporized. Perhaps there was some other natural process at work, something not yet understood. The scientific papers grew longer, more detailed, but no consensus formed. The object continued to move away, growing dimmer with each passing week, until it finally slipped beyond the reach of even the most powerful telescopes. By early 2018, 1I had vanished into the darkness. The conversation might have ended there, filed away as an interesting anomaly, a puzzle for future astronomers to revisit. But in the months that followed, something else began to happen. People started noticing things. The first reports came from amateur astronomers, hobbyists who spent their nights scanning the sky with backyard telescopes. They posted on forums and message boards, describing brief flashes of light that appeared and disappeared in seconds. The flashes didn't match known satellites or meteors. They seemed to occur in random patches of sky, far from the ecliptic plane where most solar system objects traveled. When other observers tried to verify the sightings, they found nothing. The sky remained dark and still. By the summer of 2018, the reports had multiplied. A man in Oregon recorded a video showing 3 points of light moving in formation across the night sky before winking out